In this video, I am going to solve a sample problem about helical spring. Here's the problem. A stiff bar of negligible weight transfers a load P to a combination of three helical springs arranged in parallel as shown below. The springs are made up of the same materials and out of rods of equal diameters. They are of same free length before loading. The number of turns in those three springs are 10, 12, and 14 respectively, while the mean diameters are in the ratio 1:1.2:1.4 respectively. Find the distance x such that the bar remains horizontal after the application of the load P. Okay. So ang condition is same material, equal diameter sa rod, and then given ang number of turns as well as the ratio of the mean diameters. What is asked is the distance x, so that after P is applied, the bar will remain horizontal. Okay, so we will start our analysis by considering the equilibrium equation. So we identify the resisting force of the three springs. So this one, P1, spring number 1, 2, and 3. So here you have P2 and then P3. So our equilibrium equation is summation of force vertical equal to 0. And we have this one. Okay. The other one is summation of moment. Pero sa last na, we'll use summation of moment when we solve for x. Okay. So after this compatibility equation, this will be our equation number 1. So sa compatibility equation, let's consider the spring. And from the condition, the bar will remain horizontal. So pag apply sa load, makompress ang tulo ka springs and then remain horizontal, it means na same ang deformation. Same delta. So delta 1 equals delta 2 equals delta 3. Okay. So we have three unknowns, P1, P2, P3. So we need three equations. We already have equation 1. So we need 2 more equations. Okay, from here, we will equate 1 and 2. So delta 1 equals delta 2. The other one is delta 1 equals delta 3 or delta 2 equals delta 3. So that we will have 3 equations. Okay. So let's consider this equation. Delta 1 equals delta 2. So we'll compare the expression of delta for spring 1 and spring number 2. And back sa conditions, made of the same material, therefore, same ang modulus of rigidity out of rods of equal diameter. So same ang diameter. So 64 will be cancelled out. G1, G2 cancelled. D1 and D2 cancelled. 64, G1, and then D1 and D2. And based sa condition, for the number of turns, we have 10, 12, and 14. So this is N1, N2, and N3. And for the mean diameter, okay, this is D1. 1.2 is D2. 1.4 is D3. So, D2 is 1.2 D1 based sa ratio. D2 is 1.2 of D1. Therefore, the mean radius is R2 is equal to 1.2 R1. So next one is i-substitute nato ang R2 there sa right. And we have this one, this equation. P1 R1 cube, N1 is 10. R2 replaced by 1.2 R1. And then N2 is 12. And then 1.2 raised to 3 times 12, we have this one. Oh, makancel na yun ang R1 cube. And then 10, i-divide sa right. We have P1 equal to 2.0736 P2. This will be our equation number 2. And then the next equation or condition is delta 1 equals delta 3. You can also use delta 2 equal to delta 3. Same expressions. Makancel ang 64, G1, G3, D1, and D3. And then from the ratio of the mean diameters, D1, D2 is 1.2 D1, D3 is 1.4 D1. And the mean radius is R3 is equal to 1.4 R1. And then we substitute this one sa equation. The result is this. And then simplify. Cancel ang R1. And then 10, i-divide sa right. We have this one. And this will be our equation 3. So the next step is to substitute equations 2 and 3 to equation 1 so that we can express this equation in one unknown. So P2 will be replaced by P1, P3 will be replaced by P1 so that using equation 1, the only unknown is P1. Okay. So substituting equations 2 and 3 to 1, we have this one. Okay. From equation 2, P2 is P1 over 2.0736, this one. And from equation 3, P3 is P1 over 3.8416. So i-add ang coefficients 1 plus 1 over 2.0736 plus 1 over 3.8416. After that, i-divide siya sa 1. 1 over the total coefficient of P1. And we have this one. 0.574 of P. Okay, next, we will substitute this one, P1, sa equation 2. And we can get P2 in terms of P. So from 2, okay. So 0.574 P. P1 ha? 0.574 P divided by this one, we have P2. And the result is 0.277 P. And from equation 3, this P1 0.574 P divided by 3.8416, the result is 0.149 of P. Okay, so after this, we sum up moment about spring 1. Now, P2 is in terms of P. P3 is already in terms of P. So when you sum up moment about point 1, P will be cancelled out. So we only have X as our unknown. So P2, summation of moment about 1, P2 counterclockwise, so positive force times distance plus P3 counterclockwise, so P3 times distance 12. And then P is clockwise, the moment of P is clockwise, so P times x. And then you substitute the expressions of P2 and P3 dire. Oh, and then P will be cancelled out. And we can solve for x. X is 3.45 feet. Okay. So that's the answer for this problem. Thank you for watching.